Here to explain you the question jump game. So let's start the question. So what the question says, you are given an integer array nums. You are initially positioned at the array first index, and each element in the array represents your maximum jump length at that position. So it means that from the given test case, we can see that suppose you have given this array. So what you have to take this. Suppose you have here. So the main goal is to reach the end position. Suppose you are at the index 0, or in the question says itself that you are initially at index 0 and you want to reach at index n minus 1, or say the last index. And what are these numbers says to you? These numbers says that the maximum jump you can take from this particular index. So suppose you are at index 0, then you can take a maximum jump of 2. It means that you can reach 1 or 2 index. Suppose you are at index 1, then you can reach a maximum of 3 jumps. It means that you can reach index number 2, index number 3, and index number 4. Suppose you are at index 3, then suppose you are at index 2, then you can reach index number 3. Suppose you are at index number 3, then you can reach index number 4. And your goal is to reach the index number 4, which means the last index. So how can you reach there? So according to this question, we can take a greedy approach for it. How? So we always we take a maximum of the maximum reachable distance every time we reach a particular index. Suppose we are at index number 0. So what the maximum index we can reach? We can reach 2. We can reach 2th index. So this is the maximum distance we can reach. Suppose we are at index 1. So what the maximum index we can reach? Again we keep a track of it. So well, we can also check that can we reach index number 1 or not? Yeah, we can reach index number 1 because the maximum index is here. So we can reach maximum index number 1. So here what is the maximum jump we can take? 3. So we can reach to index number 4 itself. So if we reach the last index, then we can return my answer. Same as this index. So here we can see that 2 is the answer. From the question itself, represent the maximum, then return 2 if you can reach the last index, or false otherwise. What this test case says to you? 32704. So at index number 0 you can reach to up to 3 index, that is 1 2 3. So you can reach there. So these all indexes between 2 and 0 are all are reachable. So you can take to this index. So what the maximum distance you can reach from it, from here? This. Here you can reach. Again you can reach this index. Yes, we can reach it this index. So what is the maximum distance we can reach from here? Here. Okay. So can we reach what is the reference of 0? Can we reach there? No, we cannot reach there. So here we have written false. So constraints are 10 raised by 4. So we can take an acceptable solution of big O of n or big O of n log n. So here we can solve it by big O of n approach. So see how we can solve it. First of all, we take an the size of the array. Then we take a maximum element track, so that where we can reach the maximum reachable destination from us. Okay, so let's start from the 0th index itself. Now what we can say? So suppose first of all we check, can we reach this index? Yes. So can we reach this index? If my maxi is less than my index, then we immediately return 0, because we check that can we reach this index or not. If we reach this index, then we can try of the maximum maximum reachable distance from this particular device or from previous system. So how? So just keep updating my maxi to I plus nums I, and if this can be, then you can return my answer as 1. So this is a solution for it. Let's check it out if it is work or not. Yes, it works. Now just check out that if this is accepted or not. Yeah, this is accepted. So what is the time and space complexity for it? So the time complexity for this is big O of n, and the space complexity for this is big O of 1. So this is my final accepted solution. I hope you got it right. So okay, thanks for watching the video.